Chapter 13, Introduction to Graphs. First exercise. The following graph shows the temperature of a patient in a hospital, recorded every hour. First one, what was the patient's temperature at 1 p.m.? So look at that 1 p.m. here, and corresponding to that it is coming in between 36 and 37. That means 36.5. So we can write the answer as at the patient's temperature at 1 p.m. was 36.5 degrees Celsius. When was patient's temperature 38.5 degrees Celsius? 38 is here, 38.5 is here, and at the time 12 noon. So the patient's temperature was 38.5 degrees Celsius at 12 noon. Next one, the patient's temperature was the same 2 times during the period given. What were these 2 times? We can see here 2 times. Temperature was at 36.5 between at 1 p.m. and 2 p.m. So we can write temperature was 36.5 degrees Celsius at 1 p.m. and 2 p.m. At 1 p.m. and 2 p.m. Here D1, what was the temperature at 1:30 p.m.? 1:30 p.m. means in between 1 and 2. Here when we are moving upward, we can see here touching the horizontal line. Corresponding to that 36.5 degrees Celsius. So 1:30 p.m. temperature was at 36.5 degrees Celsius at 1:30 p.m. The temperature was 36.5 degrees Celsius, and the perpendicular, how did you arrive at your answer? The perpendicular from 1:30 p.m. meets the horizontal at 36.5. Next one, during which period did the patient's temperature showed an upward trend? We can see from 9 to 10 a.m. and 10 a.m. to 11 a.m. The temperature showed upward trend. Second question, the following line graph shows the yearly sales figures for a manufacturing company. What were the sales in 2002? 2002 we can see from here to upward, and corresponding to that horizontal line showing 4 crores. So we can write here 4 crores. Then in 2006, 8 crores. Then what were the sale in 2003? That is coming 7 crores. 2005, 10 crores. Compute the difference between the sales in 2002 and 2006. 2006 we know that is 8 crore. That minus in 2002, that is 4, which is equal to 4 crores. In which year was there the greatest difference between the sales as compared to its previous year? Here, in which year was the greatest difference between the sales as compared to its previous year? That means the greatest difference between the sales as compared to its previous year was in 2005. Here the graph is showing plant A and plant B were grown under similar laboratory conditions. The heights were measured at the end, which for 3 weeks. First week, second week, third week. Now, how high was plant A after 2 weeks? Plant A representing the dotted line. After 2 weeks, that means till here. Here the height is coming 7 centimeter. So after 2 weeks, plant A is becoming 7 centimeter high. And after 3 weeks, plant A here only reach, and corresponding to that here 9. So 9 centimeter. Now same way plant B, after 2 weeks, same 7 centimeter. After 3 weeks, it's coming here. That means 10 centimeter. How much did plant A grow during 3rd week? Plant A during 3rd week. That means here 9 centimeter and here it was 7 centimeter. So 9 minus 7, which is equal to 2 centimeter. Grow during the 3rd week. How much did plant B grow from the end of the 2nd week to the end of the 3rd week? 2nd week to 3rd week. 2nd week, that was 7 centimeter, and 3rd week 10 centimeter. So 10 minus 7. That means 3 centimeter height. During which week did plant A grow most? Plant A grew most that during the grow most in 2nd week. That means 5 centimeter. Plant A from here, that is 7 minus 2, 5 centimeter. Plant B grow least. Plant B grow least in the 1st week. We can see only 1 centimeter. Then were the 2 plants of the same height during any week shown here? Yes, same week. At the end of 2nd week. At the end of 2nd week, both the plants, plant A and plant B, is having the same height, 7 centimeter. 4th question. The following graph shows the temperature forecast and the actual temperature for each day of a week. Days here, temperature on the y-axis. On which days was the forecast temperature the same as the actual temperature? Forecast the same. We can see here Tuesday, then here Friday and Sunday. Dotted line representing forecast, and thick line, bold line, that showing actual temperature. This coincide, coming together in these 3 days, Tuesday, Friday and Sunday. So we can write that here. So we can write Tuesday 20 degrees Celsius, and Friday, that is 15 degrees Celsius, Sunday 35 degrees Celsius. Actual and forecast showing the same temperature. B. What was the maximum forecast temperature during the week? Maximum forecast temperature is 32.5. Here the maximum during the week is here 35. Here this line. So 35 degrees Celsius. So we can write the maximum forecast temperature during the week was 35 degrees Celsius. The minimum actual temperature during the week is 15 degrees. So we can write in sentence, the minimum actual temperature during the week was 15 degrees Celsius. That was 15 degrees Celsius. Then on which day did the actual temperature differ the most from the forecast temperature? Here we can see the most, it is on Thursday. The difference maximum is coming here on Thursday. So in sentence we can write from here, the actual temperature differ the most from the forecast temperature is on Thursday. Fifth question, use the tables below to draw a linear graphs. The number of days a hillside city received snow in different years. Here we can mark that as the graph, x-axis as years and y-axis representing days. And according to the table, in 2003, 8 days snowfall, and in 2004, 10 days, 2005, 5 days, 2006, 12 days. So we can draw the join. First we have to mark the points here according to the table and then join the points using the scale. Here x-axis is taken as 1 year is equal to 2 units, y-axis 1 day is equal to 1 unit, that is the scale. This is the linear graph representing the given table. 5b, the question, population in thousands given of men and women in a village in different years. Years 2003, 4, 5, 6, 7. So in the graph we can mark here in the x-axis year 2003, 4, 5, 6, 7. And here the population in between, it's in thousands, 12 to 13.6. So we can mark the y-axis as 11, 12, 13, 14. This side population in thousands. And first we have to mark that the thick line representing men, dotted line for women. First we can look at the points, locate the points here. Number of men in 2003, that is 12. 2003, 12. 2004, 12.5. 2005, 13. 2006, 13.2. 2007, 13.5. Then we can join that by using the scale all these points. Same way for women also we can mark the point. 2003, 11.3 here, then 11.9, 13, both it is coming together the same, and 13.6, 12.8, that by the dotted line. This is the linear graph representing the given table. Question 6. A courier person cycles from a town to a neighboring suburban area to deliver a parcel to a merchant. His distance from the town at different times is shown by the following graph. First one, what is the scale is taken for the time axis? Time axis, that is x-axis here. This is the distance. So what is scale is taken here? We can see 8 a.m. to 9 a.m. That means 4 units in between every hour. So we can write the scale is taken here in the x-axis is 4 units is equal to 1 hour. The x-axis is 4 units is equal to 1 hour. The scale taken, the sentence, the scale taken for the time x-axis is 4 units is equal to 1 hour. Then how much time did the person take for the travel? He reached by 11:30, started 8 a.m. So 11:30 minus 8 a.m. So he traveled, that is 3 hours 30 minutes. He traveled 3.5 hours. How far is the place of the merchant from the town? Here 22 kilometers. The place of the merchant from the town was 22 kilometers away. Then 22 kilometers away from the town. Next, did the person stop on his way? Explain. Yes, he stopped in between 10 to 10:30. The graph is showing horizontal. So we can write here, yes, he stopped in between. So we can write he stopped from 10 a.m. to 10:30 a.m. The horizontal part of the graph, the horizontal line showing that he stopped in between 10 a.m. to 10:30 a.m. Next, during which period did he ride fastest? We can see this, the graph is going fast. That means from 8 a.m. to 9 a.m. he rode fastest. Between 8 a.m. and 9 a.m. that time. Seventh question. Can there be a time temperature graph as follows? Justify your answer. Here we can see the first one. Time is here, temperature on the y-axis, and it is increasing, which means according to the time, temperature also increasing. Temperature increases as the time increase. Second one, just going down, temperature is decreasing when the time is increasing. Temperature decreases as the time increases. Here time is increasing, that time temperature is going down or decreasing. Third figure, here time, the particular time, the temperature is continuously increasing at one particular time. It is not possible. We know that when the temperature increases, that it will take time. So it does not represent a time temperature graph. Here the temperature is increasing at a constant time, which is not possible. Here we can see the temperature steady. Time is increasing, but the temperature is constant or steady. The temperature remains constant when the time is increasing. Second exercise. First one. Draw the graphs for the following tables of values with suitable scales on the axis. First one, cost of apples. Here number of apples is given and cost of that also is given. So we can take number of apples in the x-axis and cost there on the y-axis. And also the scale, suitable scale. Here we can take 1 unit in the x-axis as 1 apple and y-axis that is 5 rupees. Here when we are marking that on the graph sheet, first x-axis, y-axis, and here number of apples on the x-axis, cost of that in the y-axis. And scale we have taken 1 centimeter is equal to 1 unit or 1 apple. Y-axis, that is 1 unit is equal to 5 rupees or 5 units that we can. Now plot the points 1, 5. From here 1 corresponding to 5, this point it will come, and that we can write there as 1, 5. 2, 10. From 2 corresponding to the horizontal line 10 with this point. 3, 15 from here. 4, 20, then 5, 50, 25, 5, 25. Then by using the scale we can join the line and also mark the points there on that point. So this is the point we marked 1, 5, 2, 10, 3, 15, 4, 20, 5, 25, and when we are joining the points we will get a straight line, linear graph. Now the second part of the question, distance travelled by a car. Time in hours it's given 6, 7, 8, 9 a.m. and distance in kilometer 40, 80, 120, 160 in each hour where the car reached, that is given. So we can mark the same way, time in the x-axis, distance in the y-axis. And we can plot the points 6 a.m. 40 kilometer, 7 a.m. 80 kilometer, 8 a.m. 120, 9 a.m. 160 kilometer. Now how much did the distance the car cover during 7:30 a.m. to 8 a.m. 7:30 a.m. means here, that means 100 kilometer. From 100 kilometer to 8 a.m. 120 kilometer, that means 20 kilometer traveled on that time. 20 kilometer. Then second question, what was the time when the car had covered the distance 100 kilometers since its start? 100 kilometer is coming over here and the time is at 7:30. 7:30 a.m. We can join the points. Now when we are joining the points, we will get a straight line and scale x-axis 1 centimeter, not 1, 2 centimeter is equal to 1 hour from 6 to 7. 2 centimeter is equal to 1 hour. Y-axis 1 centimeter is equal to 20 kilometer. And answer already we wrote it here. The distance of the car covered during the period 7:30 to 8 a.m. that is 20 kilometer from here to here. The distance 120 minus 100, 20 kilometer. And at 100 kilometer means that it is 7:30 a.m. Now C1, interest on deposit for a year. Deposit is here given that we can take on the x-axis 1000, 2000, 3000 etc. and interest on the y-axis. Here it's coming 80, multiple of 8. So 80, 160, 240 up to 400. And according to that we can mark the points 1080, 2160, 3240, 4000, 320 and 5400. We can join the line, join the points using the scale. Now this is the plotting the points, and then when we are joining the points we will get a straight line. So, sub questions. First one, does the graph pass through the origin? If we are extending that, we can see it is passing through the origin. Does the graph pass through the origin? Yes, we can see if we are extending the line that is passing through the origin. So we can write the graph passes through the origin. Second question, use the graph to find the interest of rupees 2500 for a year. 2500 is coming the middle line for a year. So that is coming here, which means corresponding to 200. So we can write in sentence, the interest on rupees 2500 for a year is rupees 200. Third question, to get an interest of rupees 280 per year, how much money should be deposited? 280. So corresponding to that 280 point when we are joining, that is coming over here. And that is here, vertical line, it is false in between 3000 and 4000. That means 3500 rupees. We can write in sentence, to get an interest of rupees 280 per year, rupees 3500 should be deposited. Second question, draw a graph of the following. Side of the square and perimeter is given. So first we have to plot the points here. Scale here in this side of the square. So side of the square in x-axis and perimeter on the y-axis. Scale we can take 1 centimeter is equal to 1 unit, and y-axis also 1 centimeters, here 4 units. And plot the points here. We can see it is a straight line. So is it a linear graph? We can write, yes, it is a linear graph. If we are joining the points, we will get a straight line. So we can write it is a linear graph. Second part of the question, there also side of the square and area is given. Side of the square is in the x-axis and area in the y-axis. Scale also 1 centimeter is equal to 1 unit. Y-axis 1 centimeter is equal to 8 units. Then plot the points. When we are plotting the points and after that join the points, we can see it is not a straight line. So we can write, is it a linear graph of the question? So no, it is not a linear graph. If it is a straight line, all the points when we are joining by the scale, we are getting a straight line, then only that will become linear graph, otherwise not a linear graph. Here it is not a straight line, so second part, that this question is not a linear graph.